So what? Motion of charge particle inside uniform electric field. So you want to look at what? The motion of charged particle inside what? Electric what? Electric field. Say what? When a charged particle enter when a charged particle enter perpendicular perpendicular into a uniform electric field of intensity E with velocity V, then it describes parabolic paths shown as shown below. Let us look at it now. If you have this line and we have another one here too, so assume that what this place contain a positive charge and this place contain a negative charge. So these two plates, we can call it what? Charge plates. Yes. Let me call it what? Charge what? Charge plate. This is a positive charge plate. This is a negative charge plate. Good. Do you know that what? The positive charge is the one that is what? Serve as source of electric field. Negative charge is what? Is the charge plate. Negative charge is the sink of what? Of field. So assume that what? The field is coming out from positive to what? To negative. So this is what? Field line. Good. You can observe that what the field line that is coming out from the electric field that is coming from the positive plate to the negative plate is what? Is uniform. Call it what? In uniform electric field. Good. So assume that having a what? A charge. Yeah. This is the charge. And charge here is positive charge. The charge here is positive what? Charge. If charge here is what? Is positive charge. When a positive charge particle enter perpendicular, see this is feed. Yes. This is what? Electric field intensity E. E. So if this charge positive is enter the what? I place the charge perpendicular. That is what? It will form right angle with what? Electric field. So if this charge is coming in here like this, follow this path to enter this place, it will experience one thing. What do we have here? Positive. What do we have here? Negative. So when the charge enter the what? The field, it will undergo the law of electrostatics. We're saying that what? Large charges repel, unlike charges attract. So this is positive, this is positive. This charge, is it going to move toward the positive or move toward the negative? It will move toward the what? Negative. So on getting to this field like this, the charge will what? Will bend and move upward. This is what? The parabolic curve of the what? Of the charge. Why is it that the what? The charge is moving upward? Because it will what? It will attract the negative place. The charge we have here is what? Positive. Assume if this charge here is negative, it will what? It will bend downward. Or if this place is negative, the charge will what? Will bend downward. The positive charge always bend toward the what? Negative charge. Good. The next thing you now do here is what? You can observe that what? From here, the point where the charge enter the plate to this point where the charge is what? It's coming out here. We call the point what? We call it X axis. So if you trace this what? This line like this, if the guy is moving straight line like this, charge is moving on a straight what? Straight line like this. Yes. And the point of deflection here, it will be the vertical what? Vertical component. So this place is called what? Y. And this distance here, you call it what? X. So this is what? Behavior of what? Of charge. When it's in what? In the electric what? Field. So when the charge is now what? Being electric field, the force on the charged particle will be, let's look at the force of the charged particle here. And that's say what? From here now, force, so what? The force on the charged particle. What? The force on the charged particle how are we going to determine the force of the charged particle? Recall from electric field intensity. I say what? Recall that from electric field intensity is the force over what? Over charge. From this expression, from what? This expression, I can get my what? My force. The force on the charged particle will be what? EQ. Good. This is what we call what? Equation 1. The formula of the force on this charged particle. Hmm? And the next thing is what? What will be the acceleration of the charged particle to move toward the what? This. So what? So the acceleration of the charged particle, what? The acceleration of the charged what? Particle. To know the acceleration of charged particle, we can say it from Newton's law of motion. From Newton's second law, we say that what? Force is equal to the what? MA. So to know the acceleration of charged particle now, here, the A will be equal to what? Force over what? Over mass. Plus, what is the what? The force here, EQ. Substitute for force A, you will now have A should be what? EQ over M. Therefore, A equal to the what? EQ over M. This is the formula for acceleration of charge particle in uniform electric field. If you can get the acceleration, now, what will be the velocity of what? Of the charged particle here. So the velocity of the charged particle or velocity of the charged what? Particle is from equation of what? Of motion. That's what? From equation of linear motion. We say that what? We have V should be equal to U plus AT. Here, V is U equal to 0, AT. You now have velocity will be what? AT. What is our A in equation 2? So velocity is the speed of charged particle in a uniform electric field. It will be substitute for A here, EQ over M, everything into what? T. This is the formula used to find the what? The velocity of a body of a charged particle in electric field. So now we what? Equation what? Equation 3. The next thing that we need to find is what? Displacement. As is what? Displacement X. I said what? Displacement of the charge particle. What will be the displacement of the charge particle? We also use what? Equation of what? Of motion. We're saying that what? Using x equal to the what? Ut plus half of at squared. From this, we can reduce this equation to be what? Half of what? At squared, where this here is what? 0. So what is the value of what? Of A? Substitute it here. You have displacement x is what? Half of what? What does A stand for? A is what? EQ over mass, everything into the what? T square. So if you are asked to find the what? Displacement, this is the formula for displacement of charge particle. Equation what? Equation 4. In uniform electric what? Electric field. So displacement of a charge particle in uniform electric field is what? Is this? And the next one is we can also ask to find the momentum of the charge particle. Find the what? Momentum P of charge what? Of charge particle. So we all know that what? The momentum P. I say what? Momentum P is always mass times velocity. Good. What is the mass? What is the velocity? This is the velocity here. So by substituting for velocity here, from equation 3, put it here, you will have what? Momentum should be mass. Velocity there is what? E Q over what? M T. Know that I remove this V and I put everything we have here to represent V as velocity here. By doing that, it cancels each other. So the momentum of charge particle will be EQT. If you are asked to find the momentum of a charge particle, so you apply this formula, which is what? Equation 5. The electric field intensity multiplied by what? The charge and time taken. So the last one here is you can also ask to find the kinetic energy of charge particle. Kinetics energy of charge what? Particle, which is known as what? K what? Ke. So to know the kinetic energy of charge particle, we all know that what? The kinetic energy is half of mv squared. Good. Substitute for this v here. You now have kinetic energy of charge particle should be half of what is m? Q over m. What is v? V is what? Sorry. This is v. This is v. T. Everything what? Square equal to half of m. Yes. By doing this, kinetic energy will be equal to what? Half of what? M. Everything we have here will be E square Q square will have M square into T square. This M cancel one M here. Kinetic energy later give us what? Half of what? Or let me say, it later give us what? E square, Q square, T square, everything into 2 over what? M. This is the what? Kinetic energy of a charged particle in uniform electric field. And you can see that what the charge we have here is undergo what we call what? A parabolic or trajectory curve. So this is what the explanation of the motion of a charged particle in uniform electric what? Electric field. So the next aspect we are going to treat now is what? Is dipole. And dipole movement, they now talk about what? Torque of dipole molecule or inside the what? Uniform electric field like this. We will now solve question on both.